Hello and welcome to today's class. Let's look at the next concept called triangular charge configuration. Let's discuss triangular charge configuration. Last class we dealt with the concept of the linear charge configuration. For this class here we'll look at triangular charge configuration. Alright, definition. Triangular charge configuration involves the arrangement of charges on the vertices of a triangle as shown below. So I'm saying that when it comes to a triangular charge configuration, the charges are placed at the vertices of a triangle. So let's say I have a triangle this way. Let's say I have a triangle this way. All right, I have this place. Such that the charges are placed, or perhaps the charges, this involves the arrangement of charges at the vertices of a triangle. By the word vertices there, vertices there means the sharp edges of the triangle. So this 1, 2, 3. So whenever a charge is placed at the edges of this vertex, is said to be a triangular charge configuration. Now, when it comes to triangular charge configuration, where exactly, in this case, I have Q, Q, Q. I have 3Q. So it means I will have Q1, I will have Q2, I will have Q3. So where will Q1 be? Where will Q2 be? Where will Q3 be? It's easy, please. From experience, it's better you indicate your Q1 to be here. If you want to, your Q2 to be here and your Q3 should be here. In some questions there, they'll state where it should be, right? Some questions there, they'll state where the charge to start from. Either when it starts from up in exam, they can give you that. Let's charge Q1 start at the left or perhaps right hand bottom of a triangle and move in a clockwise direction. So I'll start from here and move what? Clockwise. So Q1, Q2, Q3. That's the concept behind triangular charge configuration. Let's take some sample problem, or perhaps let's take some past questions and solve problems involved in triangular charge configuration and see how this one works. All right, let's take example under this, please. The question says 3 charges, 14 microcoulomb, 35 microcoulomb and minus 27 microcoulomb are arranged along the vertices of a triangle as shown below. It says find the resultant force on the 14 microcoulomb charge. Assume the triangle to be a equilateral triangle given distance 30 cm. All right, 30 cm. Let's get this done, please. First, what am I given? In the question there, it says that 3 charges, 14 microcoulomb and 35 microcoulomb and minus 7 microcoulomb are arranged along the vertices of a triangle. So I have 14, I have 35, I have minus 7. So these are the charges there. So let's say all right, so Q1, so let me use the diagram instead. So here's the tax. The question is in word problem. Your first part there is there, it is from the word problem there. From the word problem there, you have to mask out the diagrammatic representation of that question. Here now, I have Q1, Q2, Q3, no problem. Tax 1 done, draw a diagram. Tax 2 indicate what is Q1, what's Q3. Q1 here is given as what? 14 microcoulomb. So Q1, so specify them please. So Q1, 14 microcoulomb. Q2 is given as 35 microcoulomb and Q3 is given as negative 27 microcoulomb. So I'm given this charges here. So I expect that Q1 is here, Q2 is here, Q3 is here. So I have this place. they give us a distance. They said we should assume that this triangle is an equilateral triangle. For an equilateral triangle, we expect that all sides are equal. The distance they give us that was that we should use 30 cm. 30 cm. So 30 cm here, 30 cm here, 30 cm here. Why? This triangle is an equilateral triangle. Please, all sides are equal. So 30 cm, please. We said your first task is to convert your cm to meters. So 30 cm to meters, because what there, divided by 100, I'll have 0.3 meters. All right. So I have my charges here, and I have distance here. I have a diagram here, please. We are asked to find the resultant force at charge Q1. At charge Q1, please. So it means I'm looking for F1 resultant. That's the meaning, please. At charge Q1, that's because what there, your F1 resultant. So I'm asked to find resultant force at charge Q1. So this becomes resultant force at charge Q1, that's F1 resultant, is equal to this to this and this to this. That becomes F12 plus F1 and 3. So to get F1 resultant, I need to sum up the value of F12 plus F13. Let's get F12 from using the concept of Coulomb's law. So let's get F12. So F12, please, if you're in a previous class, you should probably know what I'm doing here. If you are in a previous class, or if you haven't watched our previous class, do it to do that. Do it to watch that, because that's the foundation there. So I expect that you know how I got to this. So let's get F1 F12. F12 is equal to K Q1 Q2 all over the magnitude of R12 all squared dot unit vector of R12. All right, I have this place. We said when you write this formula this way, first priority is to solve the R12. Let's get R12, please. So R12 is equal to the difference between R1 minus what there, R2. So that's R12. So R12 is what? R minus R2. Now we know that R signifies distance. Now look up, please. Look up, please. Look up, please. Look up. Look up, please. Look up, please. Now listen. We said when it comes to Cartesian coordinate there, if I have x here, if I have x here is positive of x, here is what? Negative of x. Similarly, I have y here, I have y here. Here is what? Positive of y. Here becomes what there? Negative of y. We said when I'm moving in an x direction, you are using what? The symbol I as in accordance to vector. If I'm moving vertically, I'm using what there? J in accordance to vector. So when I'm moving vertically, I'll use J. Horizontally, I'll use what there? I'll use high. That's, by the way, pen this man, please. Look up, please. Look up. Look up. When it comes to this concept, or perhaps vector, normally, I'm moving in two directions, either perfectly horizontal or perfectly vertical. I can't move in an inclined way. I'm only moving either perfectly horizontal or perfectly vertical. I can't move this way. It is wrong. So I only move what? In these two directions. Bear these two concepts in mind. So bear these two scenarios in mind, please. So I'm saying this, please. When it comes to this solving of this problem here, I'm moving perfectly what? Horizontal and perfectly vertical. That's all. Now let's look at this. Let's get R1, please. What's R1? Your charge Q1 signifies your position of R. Your charge Q1 signifies the position of your R1. So this R1 is the starting point. That's the origin, because what there? 0. That becomes 0. Alright. Minus into, where's R2? Look up please. Your charge Q2 signifies your R2 position. Let's get R2 please. To get R2 is easy as, look up please. For a layman will say from Q1 to Q2, year to year. No, said yes, 0.3 meters. Here becomes 0.3 meters. Here becomes 0.3 meters. So a layman will say from year to year, from year to year, the value is 0.3. We'll now come here and put 0.3. It's not done. We say when it comes to vector concept, I'm moving either perfectly horizontal or perfectly vertical. So I can't move this way. It's wrong. So this one here is not perfectly horizontal, neither perfectly what? Vertical. This one here is an inclined line, as you can see. It's inclined. So what do you do in this case, please? Now look up, please. Here is the task. I'm trying to get to Q2 from Q1. Perhaps let me call it R1. From R1 to R2. How do I get to R2? It's easy as I'm asked to move either perfectly horizontal or perfectly vertical. Here's the concept, please. For me to move to Q2, I have to draw a line this way. So I'm going to Q2, perhaps R2. I have to move this way, horizontal and what there? Vertical to go to Q2. Why? I have to follow the concept of perfectly horizontal or perfectly vertical. So I'm saying this, place I can't move this way because this line here is not horizontal, neither vertical, it's inclined. So out of the place, I have to draw a line this way and then move this way and then move to this point here. So here's the concept, please. Here is the concept, please. Let's get R2. R2, I'm moving from R1 to R2. So I'm going this way. This way here. This direct. Now hold on, please. Hold on. If year to year is 0.3, what will be half of it? That will come out there 0.15. So I'm saying this, please. We know that this 0.15 meters, 0.15 meters. That will give an entire of 0.3 meters. Alright, so I'm saying this, please. Now let's get R2. To get R2, now from Q2 to from Q1 to Q2, I'm moving this way. I'm moving this way and then this way. So this way here is an x direction, this way, and a positive x direction. So I'll have a positive value. This value becomes what? 0.15 meters high. Why I am moving horizontally? I have I. I'm done with this one here. Next as there, move upwards. If I move upwards here, upward signifies this one here. And the positive of y, and I'll attach j. So the value here from year to year is what exactly? We don't know. Yes. Watch. I want to get year to year. I don't know yet. What am I seeing? I'm seeing observe this. I'm seeing like section 1 and 2, right? In this concept here, I want to get this vertical part here. It's as easy as using the concept of Pythagoras theorem. Bring this man out. I'll have this one here. Observe please. Let's do a quick solving. I have 0.15 meters. I have 0.3 meters. Right? Here's your Q1. Q1 is here. Q2 is here. Alright. Now let's call this part here I'm looking for. Let's call it X for instance. Now let's use this concept. Let's use Pythagoras theorem. It means that Pythagoras theorem says that the hypotenuse square, that's 0.3 square, is equal to the sum of the two other sides. That becomes x squared plus 0.15 square. Point this man, what do you have here? 0.3 squared, that's about 0.09. Alright, is equal to x squared plus 0.15 square gives about 0.0225. Let's get x squared. Bring this man here. I'll have 0.09 minus 0.0225 equal to x squared. Subtract them. 0.09 minus this, the value, so x squared there. Now please, from here now, I'll have that x squared is equal to, subtract the two, I'll have 0.0225. Take the square root. X is equal to the square root of 0.0225. X is equal to the square root of the answer. That gives 0.38. So 38% in meters. So I've gotten x value at 0.38. So here from here to here is now what? 0.38. So I'm saying that here to here, that's 0.38, 0.38 meters. All right. Let's get R2. To get R2, it's easy. Move this way. Here to here is this value here. I have it here. Moving this way is a positive of y, and the value here is what? 0.3. That becomes plus 0.38 meters j. Why j? Y direction, please. All right. I have this, please. Proceed, please. Let's get R12. So R12 is equal to minus 0.15 meters I plus, minus times this minus this, minus plus is minus 0.38 meters j. All right. I've gotten the value of R12. Let's get the magnitude of R12. Please, I'll take this off. Bear this in mind, please. Copy this down somewhere so that I can recall when you need it, please. So I'll take this off. And do not forget your quadrant concept, please. All right. Let's get magnitude of R12 and proceed, please. All right. The magnitude of R12, all right, is equal to, when it comes to magnitude, it's easy as taking the square root of that term and square it. Now, I have two terms here. To find the magnitude of this thing here, I have to take the square root of each of the term and square it. Say this, please. In this case here, that becomes square root of the first term here is negative 0.1515 all squared plus second term here is what? Minus 0.38 or what there, all squared. It's easy as this, please. Pick each of the term this way, square it, and take the square root of all of them. That's all. Get a value here, please. It's now equal to, let's get the value of R12 magnitude. R12 magnitude is equal to, I'll punch this one here. The square root of minus 0.15 all squared. Next up, plus in the bracket minus 0.38 put the bracket all squared. The answer gives 0.408. 408. All right, I have this value here as my answer here. Let's get I've gotten this now. Let's get unit vector of R12. So unit vector of R12 is equal to position vector of R12 all over the magnitude of R12. R12 magnitude. This one here, I have a value of this. That becomes negative 0.15 meters I plus, minus 0.38 meters J all over This one here gives me 0.408 meters. Here is the task, please. If you are at this point here is the task, please. I'll split it into two. That is, I'll put this one out first. So I have this one first, minus 0.15 meters high over this one, 0.408 meters. I'm done. Minus this one and this together, 0.38 meters j all over 0.408 meters. Now I'll divide this to, it means that the value of the unit vector of R12 is equal to, divide this one here, 0.15 divided by 0.408. I have about, so I have a negative 0.367. We have 367. Now meter will cancel meter. I'll have I left, so I have I. The value is this, minus, divide it to 0.38 divided by 0.4408. I have the value to be 0.931. Meter cancel meter, I have j. So the value for unit vector of R12 is negative 0.367i minus 0.931 j. Please, at this junction here, I splitted it. This with this first, this with this second, and then divide them to get the value of R12 this way. Let's now put all the values inside this formula and get the exact answer for F12 resultant. And we'll now look at F13. Alright, let's substitute in value, please. Let's get F12. This equal to K is 9 times 10 to the power 9 into Q1. Q1 is 14 times 10 to the power minus 6. 10 to the power minus 6 is micro. So 14 micro Coulomb into what Q2? Q2, of course, 35 times 10 to the power minus 6. I have Q2. Alright. I have to raise for space sake. So this equal to K 9 times 10 to the power 9, Q1 14 times 10 to the power minus 6, Q2 35 times 10 to the power minus 6, all over magnitude of R12. Magnitude of R12 is this, that 0.408. This value, this one here is this. By the way, I have a square here. Put a square here. I have a square. Dot. Unit vector of R12 is all this. So in a bracket, I have minus 0.367i minus 0.931j. Alright, I have this. Let's punch all this value here and get a straight answer, and then I'll drop this one down. So I'm saying this, please. So the value of F12 is equal to, everything here should give us 9 times 10 to the power 9 times 4 times 10 to the power minus 6 times 35 times 10 to the power minus 6. Alright. Divided by 0.440 divided by 0.408 0.08 all squared. This gives me the value here. I have 45.47. By the way, everything against this, I have this in a bracket minus 0.367i minus 0.93 minus 0.931j. Alright, let's now get the final value of f12. I'll use this value to expand the bracket and see what we get, please. Alright, expanding the bracket, what do I get? From here, this one here times this. So it means that f12 will be equal to negative, this time this will give minus comes first, minus, this time this will give us times 0.367. I have minus 6.124i. Next up, this times this will give minus, this times this will give 0.931 times 45.47. I have 42.332 per se. 0.332. Here becomes j. I have j. So this is value for f12. So the value of f12 is this. Let's get so I've gotten f12 as this. Let's get f13 and then add the answer together, and that's all. Alright, so I'll keep the value of f12 pending here. So I will hang it up here. So you can easily recollect the value. So keep it on pending here. So I'll take everything here off and we'll look for the value of f13. Let's get f13. Let's get f13. To save stress, just change this as 3. 3 will be here. 3 will be here. 3 will be here. Take this off. Take this off. Take them off. Alright. Let's get f13. So put 3 here. Put 3 here. Put 3 here. Put 3 here. Let's get it first. Let's get the let's get the value of r13. R13 is equal to R1 minus R3. Let's get the value of R1. R1 is this point here and it's 0. 0 minus in a bracket. Let's do R3 please. R3. Here's my 3 here. And R3 from R1 to R3. I am moving perfectly horizontal, as you can see. Horizontal. This is a perfect horizontal. So don't stress yourself. From here to here is what? 0.3 meters. So it's easy as I'm moving a what? Positive of x. So I'll be having a positive value 0.3 meters high. I'm done. It's equal to negative 0.3 meters high. That's value for R13. So R13 is equal to this value. Let's get the magnitude of R13. The magnitude of R13 is equal to the square root of that value, which is minus 0.3 all squared. This will give us 0.3 meters. I've gotten the magnitude of R13. Let's get the unit vector of R13. Unit vector of R13 is equal to position vector, that's position vector R13 all over the magnitude of R13. Magnitude of R13. Position vector is this value here, that's minus 0.3 meters high all over magnitude is given as 0.3 meters. This one cancels this. I have minus I left. So the value for the unit vector of R13 is given as a minus I. So minus I is the value of R13. Alright, let's put all this value here inside this part here and get the value of F13. So take this off. Let's get F13. So F13 is equal to K, that's 9 times 10 to the power 9. Q1 14 times 10 to the power minus 6. Q3 negative 27 10 to the power minus 6 all over this value here, magnitude of R13, that's this value 0.3. That gives 0.3 all squared dot unit vector of R13, that's minus I. This is now equal to punch all this value here, this minus 37 point what there? 0.8. Everything here gives you negative this value. By the way, dot in a bracket minus I. So the value now for F13 will be equal to minus is plus. I'll have 37.80. Now high, by the way, I'm leaving force. Not because what there? A Newton I. By the way, please put. Alright, I said earlier that my F13 is 37.80 Newton I. I forgot to put the center of the force. In this case here, my F12, I have to put a Newton at the back, please. At the back, put Newton, add a Newton at the back, please. Add a Newton to the back here, please. Alright, let's now get the value of F13. Let's get F13, please. We expect that in exam, at least you should use 20 minutes to answer this question, please. At least 20 minutes, you are done with this question, please. Right? Alright. Let's get F13, F1 resultant. Let's get F1 resultant. Let's get F1 resultant. So F1 resultant, this one here. So F1 resultant. So F1 resultant is this, is equal to F12 F12 plus F13 F13. This now equal to F12 is what there? I have this. That becomes minus 6.124 I minus 42.332J as the value of F12. Here is Newton plus F13, that's 37.80 Newton I. Right? If I want to, I can attach Newton to each of them. Right? If I want to, I can choose to ignore the Newtons and then work with the I and J. Depends. This is now equal to, remove the brackets, I'll have minus 6.124 Newton I, attach the Newton to this, minus 42.332 Newton J plus 37.80 Newton I. I'll collect terms. I'll bring the one of I and I together. This with this are corresponding because I'm having I and I. So put these two values. Minus 6.124 plus 37.80. I have 31.676. 31.676 as the value for these two in Newton I, then minus 42.332 Newton J. So I'm saying that the exact value of F1 resultant is equal to 31.676 I, observe please, I minus 42.332 J in a bracket this way, then attach your Newton to the back. This is the final answer to F1 resultant. So F1 resultant is equal to this answer. It took me long because I want to try my best to explain this so that I can understand how it works. But once you understand how it works, it takes you 5 minutes to solve, 6 minutes to solve. You should be fast with the solvings. That's how triangular charge configuration works.